Hello everyone, welcome to my lecture series on financial mathematics. Today I am going to discuss about annuities. So what are annuities? Annuities can be identified as a series of payments with a fixed frequency. So I will take an example first. So let's assume that you are getting a series of payments of $1 at the end of each year for n years. $1, and for the third year also $1, and for the nth year $1. So they can write this as n minus 1 also $1. This is the series of payments, and this is the fixed frequency. We are the time frequency is $1, 1 year, sorry, 1 year for each payment. So how do we find the present value of this annuity? So simply we denote it as AN, present value of annuities, PV of annuities. So how do you find this A, not the present value? So in order to find the present value, we have to discount these cash flows, no, to this starting point. So we have to discount this each and every cash flow for this starting point. So yeah, this is the present value OAN. So how do we find this? So I will write down the formula first. So AN equals what? The summation of $1 by the rate of interest into t, where t starts from 1 and goes to n, since this is n for n period. So this is the formula. So you can see this discounting factor. If we rewrite this as 1 plus I to the power minus t, and this is minus t, right? So this is minus t. So then we can substitute as v to the power t. So this is the discounting factor, right? V to the power t. So we can rewrite this formula. N equals the summation. T starts from 1 and goes to n. $1 into V to the power t. For this first cash flow, it's VT1. For the second one, VT2. So likewise. So we can expand this. No, it's nothing but, since this is $1, the payment or the cash flow is only $1, we can straight away write it as V1 plus V2 plus V3 and up to Vn minus 1 and finally Vn. So we can manipulate this formula. Since this is a series, so we can find the summation of this series. So we can simply multiply the both sides by 1 minus V, and let's see what is happening. So if we multiply this side also 1 by 1 minus V, so inside this bracket it's V1, V2, V3, Vn minus 1 up to Vn. So if we do the multiplication, if we multiply this whole bracket by 1, nothing won't change. So straight away we can write it V1, V2, V3, Vn minus 1 and finally Vn. So we can omit this 1 also, but for the clarity I will write it as 1. Okay, so then this component, if we multiply this bracket by this V term, so we are getting what? This is minus V1 into V plus V1, it's minus V2, right? 1 2, this one first power and the first power, this is getting as minus V2. For the second term, it is, if we multiply V2 by minus C, what? Minus V3. And for the third term, it's minus V4. Likewise, for the n plus 1 term, it's n, Vn. This is also minus, and finally Vn plus 1. I think this is clear, no? and you can see these terms are getting cancelled out. This is plus 2 and minus v2, v to the power 2, plus v to the power 3 minus v to the power. Likewise, all the terms are getting cancelled out, and we are left with only two terms, v1 and v minus vn plus 1. So 1 minus van, we are left with v1 and minus vn plus 1. So if we back substitute this part, this discounting factor, again if we back substitute, this is what, 1 minus 1 over 1 plus I a, and v1 is what, 1 over 1 plus I, and similarly this is 1 over 1 plus I to the power n plus 1. So if we further simplify this, if I write it here, so we are left with what, 1 over 1 plus I minus 1 over 1 plus I to the power 1 n plus 1, and divided this whole part by 1 minus 1 over 1 plus I. So we can simplify this. I will write it here. This an is what, you can see, if we multiply this denominator, we can simplify this now. It's 1 plus I minus 1 over 1 plus I. So this is the denominator. You are clear, no? This term multiplied by 1 and taking the common denominator. So we are left with this, and what about the numerator part? If we take 1 plus 1 over 1 plus I out, and we are left with what? 1 minus 1 over 1 plus I to the power n, right? Since this is, here we have n plus 1 and we are taking 1 plus I, 1 over 1 plus I term out, so we are left with 1 over 1 plus I to the power n. So we can further simplify this. This is getting cancelled out, and we are left with what, n equals 1 over 1 plus I to the power n minus I. So this is the formula, the present value of an annuity up to n terms. So I will erase here this one, this diagram. So if we finalize this thing, so if we rearrange this formula or this equation again, you will get the present value formula for an annuity. So finally we can rewrite this as an equals this 1 minus 1 over 1 plus I, we can again substitute this discounting factor, v to the power n minus what, I. So this is the formula for the present value of an annuity, right? So similarly we can take the future value of this annuity also. If I erase this part here, let's say I can erase this part. So I will cut this part. Okay. So let's find out. Let's see how to find the future value now. Okay. Okay. I will erase the whole thing. So we won't require this. So let's see. Okay. So what about the future value? So you know that starting from 0 to n, present value of annuity is what? 1 minus v to the power n divided by I. So future value we write it as Sn. It is also a series. Since we know this present value, the growth factor, if we take this cash flow, the cumulative cash flow to this point, we can find the future value. So future value is nothing but what? n into 1 plus I to the power n, right? So this is the future value. Since the present value is here, we take this present value up to this point by accumulating, or the by using the growth factor. This is a compound, kind of a compound interest thing. So with the compounding factor, we can take this up to this point, and this is the formula. So what is the formula? Simplified, that Sn equals an 1 plus I to the power n. We can rewrite it as what? This you know this, previously we have substituted 1 plus I to the power minus n as Vn, right? So similarly, this is, we can substitute it again. Or let's try to simplify this first. So this is what we can substitute this an part here. 1 minus v to the power n over 1 over I. Sorry. Then we can multiply it by 1 plus I to the power n. So we can write it as 1 over 1 plus I to the power n. So substituting this part, Vn, instead of Vn, I'm substituting this 1 over 1 plus, and here we have I, then 1 minus I to the power n. If we multiply this by this term, so we are getting 1 plus I to the power n minus 1 over I. So this is the future value of an annuity. So if we take the cash flows of an annuity, let's say starting from 0 to n, one period is 1, 1, 2, n minus 1. So we take $1, $1 until this end period. This is the future value, and this is the present value. So let's say instead of $1, we are getting $10. So 10, 10, and what is the present value? N equals what? 10 n, $10, $10, or else we can keep it as it is. Let's say this n equals 5 times 5 years, so we can write it as n5 equals what? 1 minus v5 over I. So this is the formula. So I hope you understood this lesson. So give your comments, and please don't forget to subscribe to my channel. So let's meet with another discussion. So thank you.